Okay, so good morning for this semester. So it's going to be calculus 2. The subject will be more intense than calculus 1. Okay, so we gonna discuss about the thing that we gonna cover this semester, and I'm gonna only talk about the stuff that we gonna have before midterm first, and I'm gonna do the after midterm again when you have after midterm. So the thing that we gonna จริงเหรอ You hear me okay so far? Okay, thank you. I think one student told me he cannot hear me, but I think everybody fine. So please adjust your computer, or you may forget to turn on your volume or something. So for this one, it's going to be CAL2. So it's going to be CAL2. And it's gonna be like the thing that we're gonna study turned out to be more than more than 2 dimensions. So it's gonna be 3 dimension. And first of all, the thing that we're gonna study turned out to be not calculus, it turned out to be geometry. So the first part that we are having here turned out to be about geometry in 3D. The thing that you should feel turned out to be is going to be the material that you may not have background with, or you're not quite familiar with. So I'm gonna do the vector step by step, and you're gonna have this one together with physics this semester. So it should be nice to have this one first for this semester. So I chose to teach you about the vector first, that you may have them in physics as well. So this one is going to be covered about 2 weeks. So it's going to be this week and next week lecture. So it's going to be about geometry in 3-dimensional. And the rest 4 weeks turn out to be about sequence and series. The main part of this next chapter is going to be on chapter 11. So it's going to be about sequences and series. And we're going to have the series test. So that is going to be in this area. So that is going to be toughest. So this one is going to be the series test. The series test is about when we like to know whether the given series is convergent or divergent. We're gonna test them by many techniques. So that is gonna be a little bit difficult. So I would say that the hard part for this semester turned out to be on this part. So this one, I would say the hard part. So please be careful when you study this stuff. Okay, and the rest I'm not quite worried, it's gonna be okay for most of you. So you see that we gonna have like the material that we're gonna cover only for 6 weeks. So you're gonna have the video for 6 weeks, I would say that. So it's gonna be a little bit longer. However, in each video I try to I try to leave you some problem to think on your own. Like today, I'm gonna give you the solution for those questions. So for this the thing that we're gonna study turn out to be you may need to practice them, and as you know, we may have to have exam online that have to figure out how a little bit. I would think that it's going to be like we have quiz last semester. However, the question will be You will have more questions, not going to be only 3 questions like last semester. So it's going to be like a 10 question, and you're going to have the question that you have to write down the solution. So we've been practicing on that one from time to time last semester already. However, we have the paper written exam. If the university not allowed to have the paper exam, we may have to do the exam for the first part here. It's going to be online. Okay, so it's going to be in the meeting. And I will cover the detail of the exam again after everything set up, and I will show you and I will let you practice with the exam a little bit. So that is going to be our exam procedure. And I plan to have the same 5-hour exam. So normally if you have paper exam, you have 5 hours for your time. Like the first exam, you have 2 hours. The midterm, you have 3 hours. So it's going to be the time should be allowed at the same. And the thing that we're gonna do this semester will turn out to be kind of and most of the same. I'm not gonna cover the syllabus yet. I will cover the all syllabus again next Wednesday when we have this recitation. So the syllabus will be discussed in detail next week. Okay, so this one gonna be on CUCAS that I didn't do it yet, but after I have that, I'm gonna discuss the syllabus with you in detail, and I will gonna just tell you what going on only for the thing that happened before midterm. Okay, after midterm, we may hope for the best that we can do like the paper exam or something. So for this one, it's gonna be about the point distribution a little bit. So you're gonna have your assignment. The assignment will be due as usual. So it's going to be posted due and it's going to be assigned after the clip or something. And I'm going to assign another homework for today on about the parallel line and the skill line that we going to cover in this lecture. So I'm going to post another one that will cover about the skill line that I'm going to explain to you today. And I'm going to let you
ที
do
หนึ่งบางกว่า
that
กูจะหลับ
another
ตาย
thing.
หรืออาจจะเกินนั้น
Okay.
มึงกลตลอดเลยสัตว์
Okay, so the assignment will be counted for 20%. Okay, and another thing will be come from your exam. Okay, so that is going to be the same as the previous semester. So it's going to be the distribution, the same as the calculus 1. Okay, and you're gonna have the clip for your assignment. Okay, so it's gonna be great and it's gonna be accumulated. And the late submission not later than 2 days. So the Blackboard gonna say that it's gonna be like not later than 2 days late. It's gonna be graded and it's gonna get 50% deduction. Okay. However, if your homework is late more than 2 days, it's not gonna be graded. So you get 0 automatically on that homework. So that is going to be the late submission. Okay, so if you submit your homework late, you get 50% deduction. However, if it's more than 2 days, you get 0 for that work. Okay, so that is going to be the thing that you have. And the assignment must be submitted as PDF file. So it's going to be on the Blackboard. And as you see that you have the first one and you will have the second one this afternoon. Okay, so that is going to be 2 homework for this week. Okay, so that is going to be the textbook is the same textbook that you have in calculus 1, and I will post the PDF file on the Blackboard. I forgot to do that, so I'm gonna post it after this recitation. So you're gonna use the same textbook as you have for your calculus 1. Okay, so that is going to be the thing that you have. and the exam before midterm will be conducted. I would say that it's going to be online. However, if something happen, yeah, I have to answer. Okay, so I will have time for question later, but I have to finish this one a little bit. So the thing that you're gonna have for exam, we're gonna try to do online for it not quite working. So we're gonna have to wait for the new university announcement a little bit. Okay. Any questions so far? So you can just ask the question now. Okay, so for this, like I said, we're gonna have the clip. I try to post the clip at 6 on Sunday, okay? And we're gonna have the recitation, like for discussing everything that going on, and it's gonna be on Tuesday, and we're gonna try to like give you like a week for study. Okay, so it's not gonna be that you're gonna have to watch the clip on Monday or something. So it's gonna, I try to make the recitation that is gonna allow you some time to watch the clip already. So the recitation that be on Tuesday is going to be for the clip of the previous week, not the clip that is going to be new for Sunday. Okay, so it's going to be Sunday. However, if you see me on Tuesday, it's not going to be the material on that Sunday. It's going to be the material for last week, and we gonna talk about how to watch the clip, the new one that posted on the Sunday. So that was my plan. Okay, so no need to worry that you're not gonna have time. However, after you watch the clip, you may have to do homework, okay, to practice a little bit. Okay, to like to you may have to study the quiz, and you're gonna have to do your homework. Okay, so I would say that if you have any concern, any question, do you? Or so I'm gonna go to the thing that we already covered in the clip. Okay. So if you watch the clip for this week, it's going to be about 3 hours. The first hour turned out to be about reviewing about the three-dimensional space that you may use already, that you have X, Y, and Z, and we're gonna spend time learning about the vector in three-dimensional space. Okay, so you're gonna have the x-axis, the y-axis, and the z-axis. Okay, and we have three-dimensional space, so the point is gonna turn out to be triple. So like I told you here, it's going to be triple because it's 1, 2, 3, and the component here is going to be the first component, the second component, and the third component. Okay. And we have the distance formula in order to find the length of the vector. Okay, so we have this formula because we need to find the length of the vector. So we like to find the length of vector P1, P2, okay, in the next topic. So that's why we have the distance formula, and this one comes from just the Pythagorean theorem. The next one that you have is going to be about the equation of the sphere in three-dimensional, that the technique that you use is turned out to be the same as you dealing with circle. So it's going to be about it's gonna be about the completing of square. So it's gonna be, you're gonna try to put this one into this form, and the techniques is called completing the square. Okay, so that is gonna be the thing that you already use in order to compute the center and the radius for a given sphere. Another thing is going to be about vector addition and the scalar multiple of the vector that I told you that when you have the vector u and vector v, and if you like to add them geometrically, it's going to be you draw a triangle that like this, and the vector u plus v turn out to be the vector of the side of the triangle opposite u and v. And you can find the sum between two vectors by drawing the parallelogram like this, and the diagonal gonna give you the sum of these two vectors. So this one happened in the script. And when you write down the vector, you're gonna see two kinds of notation. The first notation will be the notation with the arrow. The second one will be the one without the arrow, but we use the boldface to represent the vector instead. Okay, and you have the scalar multiple. So scalar multiple is going to be the double of v, the half of v, or maybe negative 1/3 of v. So it's gonna do the vector in the way that if you have positive number, it's gonna turn out to be same direction, and if you have negative number, it's gonna give you the opposite direction. And we're gonna have u minus v, something like this. So this picture, we not quite use them in calculus, because in calculus, we're gonna use the algebraic interpretation instead, like in the coordinate vector. So we're gonna mostly use A1, A2, A3 like this. We not quite use the picture one. However, if you study physics, you may need the idea of the picture one. And I talk about the position vector. So the position vector turned out to be the one that is going to be, some student confuse this thing with the point. So when you have the point A1, A2, A3, it can mean two things. So when you have the point, so this one I highlight the yellow one. So this one is going to be just the point. Okay, so it's going to be the point in three-dimensional, and it's represented by a triple A1, A2, and A3. However, we can consider this point also as the vector OP, and your O is the origin. So when you see point, it can be vector, and it can be vector that has the initial point at the origin. Okay, and you're gonna get the vector OP. And when you write the vector, I use the angle parenthesis. Okay, so when you write the angle, when I write the angle parenthesis like this, so it's gonna be vector. Okay, and this one is angle parenthesis. So I use this one only for distinguish between point and vector. However, you can use notation A1, A2, A3 if you feel like this one can be vector for you. That's fine. However, on the quiz, on the exam, you're gonna see this notation to distinguish from this notation, because I don't want you to confuse between vector and point. Okay, so we have that. However, if you like makes mistake by writing something like this, that's fine. You get full credit. No need to worry. Okay. However, don't confuse yourself. Okay. So if you write and you confuse yourself, I cannot help you on that. So that I use the different notation to avoid confusing already. Okay. Another one that important turned out to be about the magnitude or the length of the vector. So it's going to be, if you have vector A1, A2, A3, algebraically, the length or the norm or the magnitude. Okay, so this guy can be called length of vector, magnitude, or sometimes it's going to be norm. So it's going to be norm A is going to be square root of A1 square, A2 square, and A3 square sum up. Okay, so that is going to be the norm of vector. And when we have two vector, you'll be able to find the sum like component wise. So this one is going to be the first component together, the second component together, and the third component together. Okay, so this one already explained in detail in the clip. And you have the scalar multiple. So you have real numbers C, and you have C times A1, A2, A3. So it's going to be CA1, CA2, and CA3. Okay. So we are just introducing the notation. For so far, it's not quite calculus. Okay, we are just introducing the notation, and it's gonna be the important notation. Again, it's gonna be the vector I, j, and k. Okay, the vector I is gonna be coordinate vector, so it's gonna be coordinate on the x-axis, and the vector j is gonna be coordinate on the y-axis, and the vector k turn out to be the coordinate for the z-axis. So you can write down two notation of vector. It's going to be in terms of angle parentheses. Okay, so this is what I explained you in the clip. You have two notation, the angle parentheses, and you have the ijk way. So if you didn't see one letter like this, it means A2 equal to 0. Okay, so if you have this term disappear, so it means that A2 equal to 0. So that you have to be able to read from this kind of notation. And you're gonna also discuss about the unit vector. The unit vector turn out to be just A over norm A in order to find the vector of length 1 that gonna have the same direction as your vector A. The second clip is gonna be about the cross product, the dot product. The dot product that you have turned out to be about, okay, so the dot product that you have is turned out to be about the thing that we shall use in order to determine the angle between two vectors. And we can use this dot product in order to determine whether two vectors are perpendicular or orthogonal to each other. So that the thing that the dot product can help you. So it's going to be the first useful. It's going to be you're going to have the angle between two vectors. The second one is going to be about determining perpendicular between two vectors. So it's going to be A dot B equal to 0. So this one is going to be just the thing that we will use dot product for. And the next thing is going to be about the direction cosine. So this one, I would feel that it's going to be just one formula. Okay, so it's going to be just the direction cosine that you may have to know. Another thing is going to be used a lot in physics, and we also use this one a little bit when we like to find the distance. So when we have two vectors, you'll be able to project one onto another. So you project like the vector B onto the vector A, and the result that you have is gonna be the shadow here or the projection here. This guy is called the vector projection of B onto A. If you study physics before, okay, so it's gonna be like when you have the force, and here the physics gonna say that this guy is gonna be F cosine. Okay, so this is the same thing as you have when you study science before. However, in calculus, you're gonna have the vector projection given by in terms of A dot B over norm A squared times A. Okay, so this one is another fancy way to say F sine theta. Okay, so that is going to be this projection. So basically one formula, and you're going to have the norm of this guy. Okay, so it's going to be the norm of this guy turn out to be called scalar projection, and it's going to be A dot B over norm A. So basically, let me do one example for you. Okay, so I think you need more example to have A equal to 145 and you have B equal to 403. Okay, so if you have A equal to 145 and B equal to 403, so if I ask you to find project B, project A on B, project A on B. So basically you just write down formula A dot B over norm A square, okay, and time A. And then basically find A dot B for me. Okay, I would say B on A. Okay, so I'm gonna find A on B also. That's fine. A on B. Okay, so if I ask you to find what is called, I think I said it switch between the notation. So this one is called B on A. This one is called B on A, and this one is called A on B. So for A on B is gonna be switch between A and B. So it's gonna be B dot A over norm B square time B. Okay, so that will be two formula. Okay, so they will be different for sure. So you have the length will be is right. It's going to be different. It's going to be different. So for this one, it's going to be BA. And for this one, you have A dot B. Let's finish this one and I will explain something else. So it's going to be 4 and 6. So it's going to be 19. Okay. And norm A. So it's going to be 1 plus 16 plus 25. 1 plus 16 plus 25. So it's going to give me 40. Okay. 2. Okay. 1 plus 16. 1 plus 16 plus 25. Okay. So it's going to be 42. And you have A, which is 145. And you have A dot B, so it's going to be 19, okay? And you have B square. What is B square? So it's going to be square root 25, and it's going to be 403. Okay, so that will be the projection of AB. And if you like to find the norm, you just find the norm of these two guys. I see that your friend wondering whether how would we find the pink one. Okay, so if you like to find the projection of B of A on B, projection of A on B, the way to do turn out to be you need to project. Okay, so you need to project this B to okay. I need okay. So this vector turned out to be the projection. Okay, so this vector okay. So if you like to find, it's not going to be like the length RS that you asked me. So you need to do the new projection, and the projection of A onto B is going to be this vector. Okay, so that is going to be new picture. However, this one is going to be the projection. Yeah. Okay, so that is going to be this kind of projection. Okay, so they will be a little bit different. Okay, so the pink one is projection of B onto A, and the dark blue one is going to be the projection of A onto B. Okay, and they will have this number for that vector. Okay. So the next one that we're gonna cover is gonna be about the cross product. For the cross product, I'm not gonna go over the definition again. I will do the one that I leave it for you to do on your own. Okay. So we have to find the area of the triangle. Okay, so it's gonna be P21 negative 1 and Q301. And I showed you that it's gonna turn out to be half of A cross B. So it's gonna be half of the length of A cross B. So it's gonna be half of the length of vector PQ cross vector PR. And we find the vector PQ and PR up there. Okay, and we're gonna find the cross product between these two vectors. So in this case, you're gonna have what? You're gonna have IJK. So you're gonna, let me enlarge this guy. So for this one, I taught you in the lecture that you have this guy and you have this 4 number left. So you're gonna write down negative 1, 2 to negative 1i. And don't forget that the middle guy here is the minus sign. And you have J, it's going to be 1, 2, negative 1, negative 1, J. And you're going to add by K, so it's going to be 1, negative 1, negative 1, 2, K. Okay, so this is what I teach you before. You close this row and this column. So this is the number that you have left here. And for Shay, you have these 2 numbers together. So you copy it here. And for K, you get this 4 number. Okay, copy them correctly. So one mistake that normally students may turn out to be you copy this guy wrong, and please calculate this one also correctly. So this guy will be negative 1, negative 1. So it's going to be negative 3i. Okay, so this one, the way that we compute them, so it's going to be you multiply down, you multiply up. So it's going to be 1 minus 4, so it's going to be negative 3, and you have negative, and you're going to get what is going to be, so negative 1 plus 2, so it's going to be 1j, okay, and finally you get 2 minus 1, so it's going to be 1k. Okay, so that is going to be your vector PQ cross PR. Okay, and you're going to have negative 3, negative 1, and 1. Okay, so it's going to be negative 3, negative 1, and 1. And it's turned out to be this area. Okay, so it's going to be the area PQR. Okay, so it's going to be, you're going to have to find the norm. So it's going to be square root 9 plus 1 plus 1 over 2. So it's going to be root 11 over 2 for your final answer. Okay, so this one will be, you have to find the cross product in order to find the area of this triangle. However, if the question asks you to find the area of the whole parallelogram, it's going to be just the norm of this guy. Okay, so if the question asks you to find the area of the parallelogram, it's going to be just square root 11. Okay, however, the question asks you only half of the area because the question asks you only for the triangle. So it's going to be square root 11 over 2. Okay. The next one that we have in the lecture is called the scalar triple product. I'm saying that we not quite use the formula for the determinant like this one. However, we're gonna tend to find the base and the height here by just, if you want to find the volume of this parallelepiped, it's gonna be just, you just find B cross C first, and then you're gonna dot with the vector A. That would be just easier to find. So let's finish this one together. So you have B cross C. Okay, so you have B cross C. So the thing that we have is going to be IJK. So it's going to be 1, 0, negative 1, negative 1, 2, 0. Okay. And then you're gonna have 2I. So it's going to be 0, negative 1, 2, 0, I minus j is going to be 1, negative 1, negative 1, 0, j, and you have k, so it's going to be 1, 0, negative 1, 2, k, okay? And then the number that you have is going to be 2i, negative 1j, and you have 2k. One thing that I like you to see is gonna be, that might see. So you should check your solution. So this one is B cross C. So you should let this guy dot this guy. Okay, so you just have your solution dot with the vector B to see whether you get 0. It must be 0 if you have the number correctly. Okay, so like I said in the clip, that the cross product can be checked by, you have to dot back with the original vector B and C to see whether they are orthogonal to your vector. So it's going to be this guy dot this guy, and you see that it's going to turn out to be 0. Okay, so that's correct. And for this guy dot the green guy, you see that it's going to be negative 2. minus 1, which is wrong, okay, clearly, which is wrong. So it's not correct. Where's my mistake? 2k, I have minus sign here. Yeah. Help me a little bit. Why did I not get 0? 2 minus 2, 2 minus, okay, I get it. It's gonna be plus then. It's gonna be plus. Okay. So for this one, I have plus because this one I get negative. Okay, so this one I get negative. So this number is -1, and I forgot this negative sign. So it's going to be negative, negative become positive. Okay. So like I said, you should check your solution. This guy dot, this guy equal to 0. This guy dot, this guy, both of them must be 0. Okay, and you have the correct B cross C first, and then you're gonna find A dot B cross C. In the clip, I forgot that you like to find the volume. Okay, so you want to find the volume. So the thing that you need is not A dot B cross C, you need absolute value. Okay, so you will need absolute value of A dot B cross C in order to always get the positive answer. So in this case, it's going to be A dot B cross C. So it's going to be 1, -2, -4, okay, dot with 2, 1, 2. Okay, so this guy will be equal to -1, -2, 4 dot with 2, 1, 2. And then you would get, so it's going to be 2 minus 2, okay, minus 8, okay, and you have absolute value. So this guy gonna give you 8. So this one will be the volume of the parallelepiped that determined by these three vectors A, B, and C. Okay, so that would be it for the question about the vector. The next thing that we have is going to be about the question about equation of the line. Okay, I taught you in the clip that we're going to have 3 kinds of equation of the line turn out to be in 3 kinds of equations. So the first one is called the vector equation, and the vector equation will depend only on direction vector and 1 point on the line. Okay, so it's going to be the thing that you need to keep that. Or it's going to be, hey, when we like to find the equation of the line, so you need direction vector, you need 1 point. Okay, another thing that can be written in terms of the equation of the line turn out to be equation in terms of parametric equation. Okay, so it's going to consist of 3 equations all the time, and it's going to give you the relationship in X, in Y, and in Z, respectively. So it's going to be same. Okay, so they are the same, however, into form. Okay, so it's going to be into representation. So it's going to be just same thing. However, the next thing that you can solve is going to be you can solve for t from each equation. So this one you can solve for t, solve for t, solve for t, and you allow to obtain the thing that equal to each other in terms of symmetric equation. And the symmetric equation will have one problem when you have a or b or c equal to 0. So you're gonna not get this guy on the bottom because it turned out to be undefined. So you must write in terms of something like a x equal to x0, and you have relation only on y and z. Okay, so this one is about the symmetric equation. And I taught you how to find equation of the line already. I taught you about how to determine the intersect line, how to determine the parallel line, and you have the skewed line that do not intersect nor parallel. So for parallel, it's going to be just when you have L1 and L2 like this one, you have the direction vector V1. Okay, so the direction vector V1 and the direction vector V2 on L2. So you get V1 and V2 are parallel. Okay, so it's going to be V1 parallel to V2. Okay, that your parallel line, and you're gonna have the skewed line. I taught you in the clip that it's going to be different from two-dimensional. So when you have two-dimensional, it's going to be just parallel, okay, parallel like this, or it's going to turn out to be intersect. Okay, so it's going to be parallel or intersect. However, if you have three-dimensional, sometimes it's not parallel, it's not intersect, it's going to be skew like this one. So it's going to be on a different plane that the vector are not parallel. Like you can see here, the vector are not parallel. However, these two lines will not be intersect at all in three-dimensional. So it's going to be pointed in different direction, and you not gonna have it intersection point at all. Okay, so it's gonna be called skewed line. Okay, if you gonna call this in Thai it's gonna be ไขว้คือแบบนี้มันจะเรียกว่าไขว้กันนะคือมันจะไขว้กันอยู่คนละที่อย่างเงี้ย so that the English name has skewed line. Okay. Okay, so I'm gonna finish today by showing you the thing that I left. Okay, so for this example, I chose to leave it to you because I like you to be able to see how to determine point, determine vector from the line given you in the form of symmetric equation and parametric equations. So for this one, okay, let's discuss about the point. So the point that you have here is going to be, you see that the first one, you not see any constant. So this one turn out to be, if you write this one, it's going to be 0 plus t. Okay, so you see that the point for the first line turned out to be 0, 1, 2. And the vector for the first line turned out to be 1, 2, 3. Okay, so that is going to be the direction vector. And for another one, I taught you in the clip that when you like to see the point, it's going to turn out to be here, here. Okay, so it's going to be here, here, and here. So this one, the point turned out to be 3, 2, 1, and the vector turned out to be on the bottom. Yeah, so it's going to be on the bottom. So it's going to be -4, -3, 2. And you see that the vector v1 and v2. Okay, so you see that v1 and v2, they are not parallel. Okay, so they are not parallel. Okay, so v1 and v2, they are not parallel because they're not multiple of each other. So in this case, you're gonna say that this guy are not parallel. Okay, so since so you have L1, L2 not parallel. Okay, so it's gonna be not parallel for these two lines. And the next one, you have x equal to t, y equal to 1 plus 2t, 1 plus 2t, and you have z equal to 2 plus 3t. Okay, so you have x, y like this one. Okay, you're gonna show that they are not intersect. Okay, show L1 and L2 not intersect. So this is gonna be the next point that we're gonna show. So basically, you can plug in x into L2, y into L2. Okay, so you put x and y into L2 and solve for t. And solve for t. Okay, so you have x equal to this guy, y equal to this guy, so you get t minus 3 over negative 4. Okay, and you have equal to, you have 1 plus 2t minus 2 over negative 3. Okay, and you see that you're gonna be able to solve for t by you just solve linear equation plus 9. Okay, and this one will be negative 4 minus 8t. Okay, and plus 8. So you get 5t equal to, okay, negative 5. So you must have t equal to 1. Okay, so you have t equal to 1. Negative 1, sorry. 3 equal to negative 1. Okay, so you have t equal to negative 1. So you have that. So you have x equal to 1, y equal to 1 plus 2 equal to 3, and you have, sorry, x equal to negative 1. So it's going to be 1 minus 2 equal to negative 1. And you have z equal to negative 1. Okay, so you have x, y, and z turn out to be the same number. This one is just a coincidence. Okay, it's not always that you're going to have x, y, and z are equal. However, it's turned out that when t equal to negative 1, they are. So you have the point, which is negative 1, negative 1, and negative 1. Okay. However, if you put this one on L2, okay, so if you put this guy on L2, so you get negative 1 minus 3 over minus 4 equal to negative 1 minus 2 over negative 3 equal to negative 1 minus 1 over 2. Okay. It's turned out that, okay, so you have 1 equal to 1 equal to negative 1. Okay, so it's going to be turned out that you have 1 equal to 1 equal to negative 1, which is a contradiction. Okay, so here this guy is false. Okay, so this guy is false. So this one, you're gonna conclude that L1 and L2 do not intersect. Okay, so we're gonna have L1 and L2 are skewed line. Okay, so you're gonna have the conclusion that they are skewed line. Okay, so this is how we show that this L1 and L2 are skewed line. The thing that you're gonna show is gonna be the green one. Okay, so the green one, and the yellow one. Okay, so it's going to be not intersect and not parallel. Okay, so it's going to be here and it's going to be here. And the conclusion turned out to be they are skewed line. I will post one homework for you to follow this example, okay, on the Blackboard today. Okay, so you have to be able to show that these two lines are skewed line, okay. The previous one only argue about the equation of the line, okay. I didn't post this one yet because I feel that you may need to some explanation a little bit in order to do the homework correctly. Okay, so this one, so you can follow this example or you can follow this previous example that we did in the clip. Okay, so it's gonna be on the page 33 that you can also follow. Okay, so this one is the question that showing that two lines are skewed line. Okay, so this one is an extra example, okay, that we cover during this recitation lecture. Okay, so I would say that that would be it for today lecture, and it's gonna be so we're gonna see each other again next Wednesday according to that schedule, and we're gonna have the new video clip this Sunday, okay, in order to cover the next topic that is gonna be about the plane. Okay, so it's gonna be the next topic, and it's gonna be the final topic for this chapter. Okay, so it's gonna be line and plane. Okay, so any questions so far? Or if you have question, I gonna stay for a while, okay, after this, so you may ask question. By the way, similarly, you're gonna have the suggested homework problem from time to time. Okay, so this one like exercise 12.2 that you can study from the textbook. Okay, so I'm gonna suggest some homework problem in the handout. like we did for calculus 1. Okay, so you can just practice with those problems. Okay, so like here it's going to be exercise 12.3 in the textbook. Okay, so that's it, and see you again next Wednesday. Bye bye.
อาจารย์
ครับทีม
เดี๋ยวอาจารย์จะโพสต์บันทึกไลฟ์นี้ใช่ไหมครับ
ใช่ครับจะอยู่ใน Blackboard ครับ
ได้ครับขอบคุณมากครับ